All right, here's some homework help for problem 1-77 from the homework 1.2.3. We are going to work on A and B. Both problems are going to use something we call point-slope form. And point-slope form is what we do as y minus y1 equals m x minus x1. Okay, y1 we get from our point that they give us, so that's y1. The other point is going to be x1. And m is going to be our slope. And we have all of these things because they give us that point and they tell us a line that it's perpendicular to. Okay, so what we learned in lesson 1.2.3 is if you know the slope of a line, you know the slope of a line perpendicular to it because it's its opposite reciprocal. So if the slope of this line is -2/5, the opposite reciprocal is +5/2. Because if that's negative, the opposite is positive and the reciprocal is flipped. So we can start plugging things in. Y minus a -3 from up here equals our new slope, which is 5/2, x minus our x1, which is 0. We can then start working this out algebraically. So we have y minus a -3. That's the same thing as y plus 3. Two negatives make a positive. We can distribute this 5/2 in. 5/2 times x is 5/2x. And then 5/2 times 0 is still 0, so we're good there. Now just one more step, we got to move this 3 over, so we subtract it onto both sides, and we're going to end up with our line that they are looking for, y equals 5/2x minus 3. And that would be your answer to part A. Okay, again, we just use this thing called point-slope form. It doesn't come up a lot in geometry, something in algebra. It'll be used again in algebra 2. And they just like to have us practice it so we don't forget it. Okay, we're going to do that again with a parallel line this time, and our equation is as such. And so I want to rewrite it down here so I don't forget it. I believe it's minus 3x plus 2y equals 10. I'm going to get this into a form where I can recognize what the slope would be. So I'm going to get y by itself. So I'm going to have 2y equals, I'm adding 3x to both sides. And so I get 3x plus 10. Now I'm dividing both sides by 2. And what I end up getting is y equals 3/2x plus 5. Now that is the line. That's the same line as they gave us in the problem. I just move things around so I have it in a form where I can know what the slope is. So the other thing we learned in lesson 1.2.3 is lines that are parallel have the same slope. Okay, so I'm going to start plugging in. I'm going to use that that slope intercept form again. This time that's my x1, the 0, and the 7 is my y1. So I got to remember it's y minus y1 equals m x minus x1. Y1, if I go back up, is 7, so y minus 7. If the line is parallel, we need to use the same slope. So to the contrast of this one, we used 5/2 because it was perpendicular, and so we had to do the opposite reciprocal. This one is going to be parallel, and so we have to use the same slope, so we're going to use 3/2 x minus x1, and our x1 is going to be 0. Okay, so again, we are going to distribute the 3/2 to both of them. You get y minus 7 equals 3/2x, and then 3/2 times 0 is 0, so we're good right there. Last thing we got to do is add 7 over, plus 7, and our answer to be a line that goes through that point that is parallel is 3/2x plus 7. Which you'll notice, to make sure that it's right, my new line has the same slope as my original line, which means they're definitely parallel, and they have different y-intercepts, which means they don't lay on top of each other. And then in the first one, we know it's right because we have a slope that is the opposite reciprocal. If you would like to check for sure, you can go to that Desmos, type in Desmos on Google, type both of these equations in, type these two answers in, type in the originals, and see what you get.